Hey everyone, and welcome to this Intro to Houdini course through Grayscale Gorilla. My name is Russ Gauthier, and I'm going to be introducing you to the fascinating and sometimes terrifying world of Houdini. If you don't know who I am, I'm a creative director, a designer, animator, and ultimately a Houdini lover. I've been spending the last few years of my career doing a lot of work for big tech companies, all of the major auto manufacturers, and a lot of work for Marvel Studios, title sequences, FUI design, holograms, and tons more. You can see some of my work at robotastronaut.tv, and please give me a follow at robotastronaut_ on Twitter. So even though I'm teaching this Houdini course, Cinema 4D has actually been my #1 3D tool for 15 plus years. I love its speed, I love its flexibility, it's an amazing, amazing program. That said, when I picked up Houdini and I finally got it, I was completely blown away by the way that it makes you solve problems. The way that it approaches things is just so dramatically different. It opens up so many interesting doors, and I actually think it's a really fantastic complement to Cinema 4D. I've also taught Houdini at SVA for the last couple of years to both graduate and undergraduate computer art students. So I've seen that terrified look in their eye on their first day of class when they're starting to learn the program. And I promise you, we will make it through. So what's going to be in this course, and really who is this for? It's really an introduction to Houdini workflows. We're going to be round tripping to and from Cinema 4D. So we're going to start in Cinema 4D. We're going to do some simple things. We're going to export everything over to Houdini. We're going to do some simple things. We're going to do some not so simple things. And then we're going to take everything back to Cinema 4D for texturing, lighting, and rendering. We're going to cover some really simple but incredibly powerful tools and techniques in Houdini to help get you up to speed. That said, this is not a dynamics course, and I know that a lot of people, when they get into Houdini, they want to learn particles and they want to learn dynamics and everything, but one step at a time. I promise you, it'll be worth your while to take the time to learn the basics first, because that's going to give you a solid foundation of the program that you can build on top of. And if there's interest, perhaps in the future we'll do a dynamics course or a particles course or something. And who's it for? It's for everybody. That said, if you're already a Houdini pro, you're likely going to be pretty bored. It's really to help get people up to speed on the program if they have either never used Houdini before or if they've tried and they've stalled out. I know how it goes. I tried 5 times before this program stuck in my head, and now I'm here to help you get up to speed. It'll help to be familiar with Cinema 4D, but it's really not necessary. We're not going to be doing that much crazy stuff in Cinema that you can't just follow along. So what do we hope to achieve here? The goal for me is to really impart understanding, not just knowledge of this program. That means lots of explaining. We're probably going to stop and talk some theory. I'm probably going to draw some things badly in Photoshop. There's going to be a lot to take in. So don't sweat memorizing all these things. Don't try and memorize each of the individual nodes just yet. What I'd really like you to do is focus first on how Houdini likes you to think. Focus on how Houdini helps you solve problems in an interesting and unique way. The rest just comes with practice. You'll figure out the nodes as you go. My goal here really is to demystify this famously challenging program. We've all seen the Houdini learning curves and everybody has talked about how hard it is. It's hard, yes, but its challenge really comes in just how different it is. The way that it wants you to solve the problems is different from anything else out there, and it's kind of like learning a new language. It's hard at first. So with that, just a couple pieces of general advice before we really get started. Use it every single day, at least a little bit. You don't have to use it for hours on end to get it, but just a little bit every single day will help you retain a lot of the knowledge that you've built up. Do your best not to compare it so much to other 3D programs. There are some parallels that we can draw between Houdini and Cinema 4D in this course, but really, if you approach Houdini like you approach other programs, it's going to be very, very challenging. With that, don't use the shelf tools. The shelf tools are those juicy rows of tools up at the top, all those little buttons and graphics and things. And generally, when you open a new program, that's the first thing you do is go and start touching all the buttons and pressing all the things and seeing what happens. In Houdini, that's actually going to work against you. What those are is essentially node presets. So it's going to create a whole bunch of nodes that you don't know what they do, and the data is flying all over the place, and you aren't going to have any sense of how to actually use what you've created. And it's going to be confusing and frustrating. That said, it's okay to be frustrated. Houdini is hard for most people. It just is. Bite off small problems first. Houdini is fantastic at compartmentalizing, and we're going to see that when we actually get into the program. And my number one piece of advice, which I guess probably should have been at the top of this list, is keep a Google Doc for your own notes. There are lots of rules and tricks and gotchas that it's just good to have notes for yourself. So at this point, I'm sure you're wondering, why even bother with Houdini at all if it's so hard? Well, first of all, like I said earlier, it's a fantastic complement to Cinema 4D. It really does a great job of kind of picking up where Cinema 4D leaves off in so many ways. The other thing is it teaches you how other 3D programs work. Because you have access to the nuts and bolts of what goes on behind the scenes, it really kind of opens up that black box that is present in so many of the other programs out there. Houdini solves problems differently, and when you're trying to solve a problem, sometimes it can actually really help to see it from a totally different perspective, and Houdini really forces you to think in a completely different way. And lastly, it's just fun. It's fun to open up and play with Houdini and try something new. So we're over here in Photoshop, and I'm going to show you a simple graph that I like to show to people who have never worked with a Houdini artist or have never worked with Houdini themselves, just so that there's a sense of an expectation of how the program works. So when you're working with a program like Cinema 4D or Maya or really other 3D programs, your productivity is fairly linear compared to the amount of time that you spend. So if we have the start of our project down here, our productivity curve looks pretty similar to this, right? So if we've spent, say, 2 days on a project, we would expect to see about 2 days worth of progress. If we spent 5 days on a project, we would expect to see about 5 days worth of progress, right? So that's a fairly linear curve. Now, when it comes to working with Houdini, that curve is actually quite a bit different. So at the start of the project here, you may not see any progress for quite a while, and then all of a sudden, that productivity curve is going to shoot straight up. This time down here is really when you spend your time in Houdini trying to figure out the instructions or the recipe that actually goes into building whatever you're going to build. And then all of a sudden your productivity curve goes off the chart because you have a recipe that you can repeat to take care of the task in as many different ways as you want. So let's say we're going to build a chair, right? In Cinema 4D, what I'm going to do is sit down and I'm going to model a chair. After a couple hours, I might have one chair. If I'm going to now sit down and build a new chair, maybe it takes me a couple more hours, but now I have 2 chairs, right? We have a pretty linear progress curve. In Houdini, we tell Houdini what the recipe for a chair is. It might take quite a while to actually get there, but once we do, now we can have a chair with 3 legs just as easily as we can have a chair with 5 legs or 10 legs or a really tall back. We can have 50,000 chairs, no problem. So if your job is to just build 1 chair or 2 chairs, you'd probably want to use something like Cinema 4D or Maya. If your job is to build 500,000 different chairs, aside from questioning why you're doing that job, Houdini would be a much better tool for the task. This is the advantage of working procedurally. This is a word you hear thrown around a whole lot when people reference Houdini and the way that it works. It is a procedural workflow. So another way you can think about it, related to motion graphics and visual effects, is green screen versus rotoscoping. Green screen is a very procedural approach to cutting something out from the background, giving it some transparency. Rotoscoping is a very manual approach to taking care of that problem. Both have their uses, both are incredibly important, but they both have different areas where they shine. Over the years, I've taught myself many pieces of software. I always find that there is one thing about every single piece of software, one fundamental concept that once you understand it, it really unlocks the program for you. For Photoshop, it's layers. Yes, you can bring in a photo and you can do some simple color correcting. You can even paint on top of it. But as soon as you realize you can layer things in Photoshop, that whole program completely changes for you. For After Effects, to me, it's pre-comps. The idea of taking layers, grouping them together into their own composition that you can duplicate, you can move, you can shift, you can apply different effects to, that completely opens up After Effects. For Cinema 4D, it has to be the object manager and hierarchy. Understanding the parent-child relationship between the things in the object manager is absolutely essential to using Cinema 4D. So what's the thing for Houdini? It's data. And to be fair, all programs use data. All programs are built from code. All the data is there. You just don't necessarily get a chance to use it. In Houdini, you do. And that's what makes it so incredibly powerful. It lets you see and use all of the data. And once you have an understanding of how to create and manipulate that data, the program is totally open to you. So what is this data? In Houdini, the data mostly takes the form of attributes. They're represented in Houdini lingo and code with the little @ sign, so @p for position or @n for normal direction. Attributes are numbers mostly. They're integers, which is your whole numbers, 1, 5, -45, 150, etc. They're float or scalar numbers, 0.01, 2.0, -900.4, whatever. They're vectors, which is your XYZ, RGB, UVW numbers, etc. But then there's also things like strings, which are mostly not numbers, names, file paths, that kind of thing. So where do these attributes go? In Houdini, they live on the geometry themselves, so points, vertices, primitives or polygons, and then the object itself or the detail attributes. Attributes are like characteristics of these various geometric constructs, or classes, as Houdini calls them sometimes. So think of it as like color, size, orientation, etc. And you can have any one of these attributes live on any of these components of the geometry. So I'm over here in Photoshop, and I just want to do a very brief demonstration of how Houdini creates geometry, how it creates polygons, because that's kind of integral to the way that geometry stores attributes. It's really important to know the relationship between points and vertices and polygons specifically. So here we have 4 points just sitting out in space, and I'm going to say that we are essentially looking top down on this piece of geometry. It's just going to be a square. So we'll have our axes. This will be our z-axis, this will be our x-axis, and then pointing up, that'll be our y-axis. So we have our 4 points floating in space. Each point also has a unique point number, so it has an integer assigned to each point to let it know that, point 0 is different from point 1 and 2 and 3, etc. They also have unique positions in space to describe where they sit in the environment. So each of these points has a vector value associated with it that gives x, y, and z coordinates on the x, y, and z grid. Another way to represent that might be a little bit more Houdini-like is like this. So we have point 0 sits at -1, 0, and 1. Point 1 sits at 1, 0, 1, etc. Right? So we have p, which is position, but we have p.x, p.y, and p.z, and those are all separated out here. So we can actually just turn off these because they're represented right here. So the way that Houdini creates a polygon out of these 4 points is by making a relationship between the point and the polygon. So I'm just going to turn off the representation of our axis here, and I'm going to say we are dealing with polygon 0. And polygon 0 starts at point 0, and it draws out to point 1, and it goes from point 1 down here to point 3, and it goes from point 3 over to here to point 2, and then finally point 2 all the way back up to point 0 again. And that is polygon 0. Now, the way that Houdini understands that is by storing the relationship between the polygon and the points as a vertex, and it represents it much like this. So here's our vertex number. The green 0 is the polygon number, so polygon 0 for all 4 of these vertices. And then the number in red here represents the actual vertex and the point number is the point for that relationship. So polygon 0, vertex 0 is point number 0. That's over here. Polygon 0, vertex 1 is point 1. Polygon 0, vertex 2 is actually point 3, because that's the draw order. And polygon 0, vertex 3 is actually point 2. So that's telling Houdini what order to draw these polygons. And that's a really important thing to realize. The difference between points is that points actually sit in 3D space, and vertices really just store the relationship between the polygon and the point. So the polygon itself doesn't actually have any position data to it. It's really just the product of the points that make it up. Let's look at a little bit more expanded example of that. So here I've got a really basic grid again. I have points on all of these 9 polygons. I have point numbers on all of those points. I have primitives, right? So I'm just representing the primitive centroid as a little green dot. And then I also have primitive numbers, right? So each of the numbers for each of the primitives, much like points, it has a unique integer. So I've drawn out these little orange dots to represent the vertices of each of the polygons. The vertices don't actually have necessarily physical location. Like I said, it's really the points and the polygons relationship, but it's easier to represent this way visually. So if we look at say 0.5 here, right? 0.5 shares its point with 4 different polygons. So 0.5 shares a point with polygon 1, 4, 3, and 0. And even though it's only a single point in space, there are 4 vertices associated with 0.5. Likewise with like 0.2, you have 2 vertices. 0.3, you only have 1. So each point can actually be associated with multiple vertices at the same time. Now, we can actually add attributes to all of these constructs, to points, to vertices, to primitives, and to this entire object itself. So if I wanted to say, make all the polygons red, right? So we turn all the polygons red, and in Houdini, that's represented kind of like this, where like if this is our list of polygon numbers, it's giving us this CD attribute. And then that's broken out into CDR, CDG, and CDB, of course, for red, green, and blue. And when you're representing red, all of your CDR values for all of your polygons are going to be 1. And then you're going to have 0 for green and for blue. So that's if we wanted to apply a polygon attribute. So likewise, if I wanted to say, copy a bunch of objects onto all of my points, kind of like you would do with a object cloner in Cinema 4D. And let's say I wanted to change the scale on each of those points. What I could do is I could assign a p-scale float attribute to each of those individual points that might look something like this. So here we're looking at px, py, and pz for all of our points, but then we also have p-scale as an attribute for each of these points as well. And so each of those little clones gets scaled based on this value, this attribute. So you can kind of think of attributes in Houdini a little bit like vertex maps in Cinema 4D, but far more robust and usable in very, very diverse ways, and really at the heart of what makes Houdini special. These are just a couple of really basic examples of how you can use attributes on different geometry constructs in Houdini to execute different effects or tasks or things like that. So a little bit more about attributes. There are many attributes that are actually built into Houdini. Things like position or normal direction or color or UVs. There's tons and tons of them. But you can also, of course, make your own. You can make as many as you want, really. But you should know that the more attributes you have, the more memory is actually being used. Attributes are case sensitive, so at capital P is not the same thing as at lowercase p. The first question I get from students at this point is, can I see these attributes? I'm a visual person. I like visual things. The short answer is yes, of course you can. The longer answer is you can use your middle mouse button on a node so that you can see all of the data at a glance. You can use the various viewport visualizations, which we'll talk about. You can use the geometry spreadsheet, which is slightly scary at first, but incredibly powerful. You can use the visualize node, you can use the color node, and many, many more ways that you can actually see what's going on under the hood. So let's talk about some Houdini lingo. If you've ever heard Houdini artists talk, you've heard them throw out all kinds of crazy acronyms and phrases and everything. So the first thing I want to talk about is the object context, or really just kind of contexts in general. You can kind of think of the object context as your master comp of sorts. This is where you put lights and cameras and objects and everything. This is all of the stuff that's actually going to render when you render something. So then there's the ops contexts. Ops stands for operators. So SOPs is surface operators, and that's actually where we're going to be spending most of our time in this course. SOPs is where you do all of your creating and manipulating of geometry, so modeling tasks and all kinds of things. DOPS is dynamic operators, POPs, particle operators, VOPs, which is vex operators, and we'll actually be spending a little bit of time in VOPs in this course. And then there's many, many more. There's also MOPs, which are pretty cool. It's motion operators, and it's actually a suite of nodes that you can download as a plugin for Houdini that does all kinds of fun, kind of motion graphics-y things. So more Houdini lingo, because of course there's more. This is what a node looks like in Houdini. The node has flags. These flags do all kinds of different things. So the one on the left is your bypass flag to turn off the node. There's the lock flag. There's the template flag, which kind of ghosts the node. And then there's the visibility flag, which is probably the most important and the one that you use the most often. Nodes can pass data via node connections to other nodes. So here we're taking the box node and we're feeding it into a transform node where we're actually going to move and manipulate that box. And you can also see that we've got our visibility flag turned on the transform node so we can actually see what it is that we're transforming. This is the parameter window where you actually adjust all of the properties of the various nodes. So when you select a node, it gives you access to its parameters. These are called channels, and the channels are any of these little areas that have a number or anything in it that you can actually manipulate. Houdini has a really robust expression system built into it, and you can write expressions in any one of these channels to expand its functionality. These are the shelf tools at the top of the interface. Don't touch these, at least at first. They're really just node presets. They're going to end up creating a whole bunch of nodes and data for you that you're not really going to know what to do with at first, and it could just end up causing a lot of frustration unnecessarily. Groups is another good one. Groups are kind of like selection sets in Cinema 4D, where you set a selection and it creates a little selection tag for you. Except in Houdini, they're basically just a Boolean attribute. Your geometry is either in the group or it's not in the group. And you'll notice that most of the nodes that we come across are going to have a little field for a group. So you can actually have those nodes operate only on small portions of the geometry rather than operating on the whole thing. Subnets are basically folders of nodes that you can create. In a way, they're kind of like an organization system, but you can actually take them a step further and apply UI elements to subnets and turn them into tools. And in Houdini, those tools are called HDAs or OTLs. HDA stands for Houdini Digital Asset. And you can take a subnet of nodes, you can turn it into a tool, and then you can use it just like any of the other nodes. In fact, Houdini has lots and lots of HDAs actually already built into it, and we'll look at some of those when we get into the program. Vex and expressions. We've already touched on expressions a little bit. Expressions go inside those little channel boxes, but Vex is a very powerful programming language that's actually built into Houdini. And they are two completely different systems, even though they share a lot of the same kinds of functionality. Vex is based on C++ and JavaScript, so if you're familiar with either one of those, the structure of Vex is going to look very familiar. Attributes versus variables. We've been talking about attributes a ton, but there's also variables built into Houdini, and there's several different types. They're these kind of global variables that operate a little bit like tokens in Cinema 4D. They're incredibly useful. And then there's this sort of older system of variables, these kind of localized variables that attributes have basically come to replace over the last few years. So if you watch an older Houdini tutorial and they're talking about variables, kind of like we would talk about attributes now, that's why. They basically served the same purpose, but the attribute system is far more refined. And then Vex actually has a variable system built into it where you're able to create and manipulate localized data within Vex that doesn't end up taking up any extra memory because you're not turning it into an attribute. But we'll discuss that once we get more into programming Vex.